Hi guys, this video summarizes the categories of iterator that we will be using. Since there are so many different kinds of data structures that are organized in different ways, there are different categories of iterators that have different capabilities. Some data structures allow you to move around within them more freely than others, and because of that, the C++ library has these categories of iterators. That's a technical term here, category of iterator. The ones we're going to go through from least featureful to most are the following, and keep in mind that every category lower on the list has the capabilities of all of the ones above it. So a random access iterator can do everything the above categories can. The simplest is an input iterator that just allows you to get elements out. A forward iterator allows you to move in the forward direction through a data structure. A bidirectional iterator has all the capabilities of the previous two, but also allows you to move backwards. You can move in either direction. And a random access iterator has all of the capabilities of the previous three, and you can jump from one location to the next. You don't have to just move one location at a time. You can quiz yourself a little bit at this point and think to which data structure that we've studied corresponds to which of these categories of iterator. We've studied the vector, the singly linked list, and the doubly linked list, and those map to the forward iterator, bidirectional iterator, random access iterator in some order. One of the data structures has one of each of those kind of iterators, so maybe think ahead which one is which. What I'm going to do now is show you an excerpt from the C++.com reference documentation that illustrates these relationships in a visual way that might be a little bit easier to understand. Okay, so here we are at the reference documentation for iterator, and there's an explanation here that explains the idea of iterators and the categories. The part that I wanted to drill down into is this category diagram here that's trying to illustrate that idea I said about how we have these categories that add additional powers or capabilities. So the simplest category that we'll study is the input iterator. It only has a couple capabilities. You can use the equality-inequality comparisons, the equal, equal, and the not equal operator. So an input iterator allows you to tell two iterators apart, are they the same or not? And you can dereference them. So you can follow the iterator to get a value, but that's it. An input iterator can only do those two things. A forward iterator adds some additional capabilities. So everything an input iterator can do, a forward iterator can do as well. In addition to the input iterator capabilities, the forward iterator has the ability to increment, so move from one location to a next, and also is constructible. You can make your own constructor, your own iterator object, and you can assign them back and forth. Okay, also, incidentally, there's this multi-pass guarantee. That means that neither dereferencing nor incrementing affects dereferenceability. That basically means if I have an iterator object, I'm allowed to start at the beginning, go to the end, and then I could reassign it to be at the beginning again and use it again. So the iterator objects can be reused like that. That's what the multi-pass thing means. Okay, so a bidirectional iterator, note that it includes everything of forward and input iterators. That adds the additional capability of being decremented. So forward iterator only goes forward. You can increment a forward iterator but not decrement it. But a bidirectional iterator has the forward motion with plus plus and also the reverse motion with minus minus. Okay, and then the biggest category, random access, that adds a whole bunch of different capabilities, includes everything that bidirectional forward and input iterators can do, but adds all these other operations. So a random access iterator can do more stuff in addition to everything that we already talked about. It has plus and minus operations, so you can add and subtract them. You can add one location to another, subtract one location from another to get their distance apart. And you can compare them with less than, greater than, because they represent different comparable locations. You can add or subtract numbers to them to jump a few steps at a time. So with plain bidirectional iterators, you can move one location forward or backwards. That's it, one at a time. If you want to move three locations, you have to plus plus three times. But with a random access iterator, you could just jump three times. You could say iterator A plus equals 3 and move 3 ahead. Now that we've covered those categories of abstract iterators, these abstract categories like forward iterator, bidirectional iterator, random access iterator, I want to just link those to the three data structures we've covered. So now I'm going to kind of answer that question I asked earlier, which data structure corresponds to which kind of iterator. A singly linked list iterator, so the std forward list iterator type, that's a forward iterator, And the rationale for that is because you can start at the beginning of a singly linked list, move to the next location by following next pointers, but there's no efficient way of moving backward. To go backwards, you have to kind of remember where you were already, and the nodes don't have that capability in an efficient way. So forward list gives you a forward iterator. The way it works is the beginning, so the location of an iterator, the way that we would represent that is a pointer to a node. So internally, the standard forward list iterator data type probably has a pointer to a node. I say probably because we are honoring encapsulation. The authors of standard forward list iterator could have coded this any way they want, but most likely they have some kind of pointer to a node. So the beginning location would be the head pointer, the first node. The past the end location, the end would be null pointer, because if a node pointer ever reaches null pointer, then it's past the end. Comparison works between two iterators just by comparing their pointers to see if they point to the same node object. In order to dereference an iterator to get its element, you follow the pointer to a node and then call the element accessor function to get the element out. And to advance to the next location or past the end, you go from the current pointer location to the next. You follow the next pointer. A doubly linked list iterator is a bidirectional iterator, so it has all the forward iterator capabilities, but also adds the ability to move one step at a time backwards or reverse. And that's because of the prev pointers. The whole point of a doubly linked list is that it has both the next pointer to move deeper into the list and the prev pointer to move backwards or shallower into the list. So the implementation of this probably has a pointer to a node. An iterator needs to know what node it's at right now, and it also needs a pointer to the dummy node so that it can tell when it's reached the dummy node. So in order to start at the beginning, we would just create a pointer to the first node, which is dummy's next. In order to create a pointer to the dummy, or the past the end location, we'd give a pointer to the dummy. We can compare two pointers by comparing to them to see if they point to the same node. And just like the singly linked list, we can dereference a doubly linked list iterator by following the pointer to the node and getting the element out of the node object, and we can advance by following a next pointer, and we can retreat or do the opposite of it, advance, decrement to a previous location by moving from the current node to the prev leftwards. Finally, the vector iterator. Vector iterator is a random access iterator, so it has all of the capabilities of bidirectional and forward iterators, and also the ability to jump around a few steps at a time. So probably a iterator into a vector has a t star pointer, so a pointer to a location within the backing array that actually stores the elements. To begin, we get the address of element 0. To end, we get the address of elements at size. Remember, size is one too big to be a valid location. So this is the one past the end location. To compare two iterators, we just compare their pointers to see if they point at the same array element. To get the element at a given location, we dereference the pointer. To advance, we plus plus the pointer, and to retreat, we minus minus the pointer. And then to jump k steps ahead, we just add k to the pointer, and that's how pointer arithmetic works.